Okay, so let us start this topic. Correct or not? And we completed till over here. We completed the loop rule. We completed the parallel and series part, and how the battery is connected with stone breeze, parallel connection, also series connection, also, isn't it? Now we have one question over here that it is saying that we have these 4 to 5 capacitors and they are connected in this fashion. The question is they are asking that find the equivalent capacitance, isn't it? Now, this is something like, look over there, this is something of a Wheatstone bridge only, but they have a different arrangement. Go ahead or not. Try to see how to understand whether they are a Wheatstone bridge or not. So you can see that they have been connected like in the same fashion that I'll show you. That this is my 4C, then there is a 2C in the parallel way or not, because the charges is getting divided, isn't it? Yes. And then once again at 2C, the charges are getting divided into 7C and 3C, isn't it? So 7C and 3C. What the idea? Got it. Next, when you see, this is once again the 4C is attached with the 7C or not. So look over here, I attached my 4C with the 7C. Got it. And then for at 7C it is divided into two parts. One is 6C, which is combined with 3C part, isn't it? So isn't this is looking like a Wheatstone bridge? Yeah, always. When this kind of arrangement you will get, it is a Wheatstone bridge only. Are you able to get me? Okay, so when it is a Wheatstone bridge, now you see over here, I have to take the ratio. So product of this and this and product of this and this will be same or not? If it is same, then the net charge through this is how much? Zero. Are you able to get me? So what kind? Yeah, so what kind of a circuit I got? 4C, since that is 12, because it's a balanced Wheatstone bridge. Okay. This is like this way, isn't it? This is point B, this is point A. So this is 4C, 2C, 3C, and 6C, isn't it? So can we say that 4C and 6C are in series and 2C and 3C are in series? Are you able to get me? So C equivalent will be what? It will be series of this and then this. So it is like, let's suppose if both of them are C1 and here it is C2. So C1 plus C2 will be my net equivalent capacitance or not? What is C1? It is 4 into 6 by 4 plus 6. You got it how I have done it? Yeah, because these two are a series connection, isn't it? And next it is 2 into 3 plus 3 plus 2. So what I got? 24 by 6, 4, 10, isn't it? And this is 6 by 3, 2 plus 5. So LCM is 10, 24, 5 2s are 10, 6 2s are 12. So that is 36 by 10 is my net capacitance. Are you able to get me? Which is 18 by 5 or 3.6. Is that clear? Yeah, it's a balance with some race. If the ratio, if this ratio x1 and x2 is not equal to x3 and x4, x1 x2 is quite or not. And for unbalanced Wheatstone bridge, there is a special way to solve it, quite or not. And that is there in the HCV. First, we'll learn all the balanced cases, means normal cases, then we'll go on unbalanced cases. Is that clear? ठीक है, चलो आगे बढ़ा जाए. Solve this question then you will understand what's the meaning of a straight one. Acha, how to solve it? You have a question now. First thing is that. Acha, see how to solve it. In these kind of long kind of questions where there are straight wires and all, and there is only capacitance, no batteries. Start marking the point potential. What you need to mark? Point potentials. Go ahead on. So look over here. This is V potential at A, isn't it? This is connected over here. Then this is also potential at A. Yes. And in this wire there is no capacitance. So that means this is potential of A also, and this is also potential of A. Got it or not? Now here it is B. So this point is, since it is present on this, it is top of that, but here it is intersecting or not. So that means that this is having potential of B, and here there is no capacitance. So potential of B, and this is also potential of B. Got it or not? Got it. Next thing, when you go on doing, this is also potential of B, but here it is jumping over here, isn't it? This means that this has jumped. So if it is jumped, then I don't need to consider. Are you able to get me? Yeah. So basically, then I have to find the equivalent. This is my first step. Mark all the intersections. What is the first step? Intersection. Then write VA and VB. Write what? VA and VB, and go on adding the capacitors. Are you able to get me or not? Yes. So look over here. When you see the first, there are two capacitors between VA and VB or not? These two, isn't it? So I'll draw. Let us draw. So first there are how many capacitors? Two capacitors between VA and VB. Got it? Is that clear? Next, there is one more capacitor between VA and VB. Is that clear? Yeah. Then one more capacitor is between VA and VB. Yes. This is V of A. So look over here. There is first we have done this. We have done this. Then I'm left out with this. So one more capacitor between VA and VB. Got it? And then you once again see two more capacitance are there. So you got the whole circuit or not? So which one was looking as tedious, now it is what? It's just a simple parallel and series arrangement, isn't it? That's all. That's what you have to do always. That mark the potential, and then you just wrote the capacitance. So this is C, this is C, this is C, this is C, this is C and C. So this is what? If they are in series, so this is C by half or not? And this is also C by half, isn't it? So C equivalent is how much? C by half plus C by half plus C plus C. So net equivalent capacitance is how much? 3C. Got it? Are you able to get me? And it is connected with how much volts of battery? 60. So therefore, charge on the whole circuit is how much? It is 180. Q is equal to CV, isn't it? So 180 C. Are you able to get me? Isn't it? Are you able to get me or not? Now it is asking that find the charges on each capacitors. That was also the question. Yes. Okay, so it is asking about charges also. So look over here. Whatever is charge, see, on this the charge will be what? Q1. This will be what? Q2. Since they are in parallel, so here also Q2 and here also how much? Q1. Are you able to get me? So, but first I'll mark different Q3 and Q4. Q3, Q4. Got it or not? So you got your potential, you have to find the charge, isn't it? So Q1 is exactly equal to Q4. Are you able to get me? Net capacitance is how much? C by 2. So net capacitance divided by what? Sorry. What am I saying? Net capacitance in this wire, which is C by 2, divided by total capacitance, which is how much? 3C into the total amount of charge or not. So which is 180C. So how much is this? 6 3 is 18. So this is total 30C charges. Are you able to get me or not? In Q1 and Q4, it is how much? 30C. Is that clear? Then in Q3, Q2 and Q3, it is how much? Basically you do. So then here in one is C, net capacitance is 3C. Then the total charge is 180C. So this is basically how much? 90C. Are you able to get me or not? 90 or 60? How much is it? 3 6 are 18, no? 60C. Got it? So तुम्हारा तुम्हारा वो जो एक डाउट था I yo there were two capacitors, three, four, ऐसा कुछ 5 कैपेसिटर्स थे ना, है ना? And this one was connected like this way, है ना? And this one was connected like this way, isn't it? ऐसा था ना कुछ? हाँ, so look over here. If this is potential A and this is B, always mark the potential. Mark 2 points A, B. Right or not? What is potential over here? V of A. Here also V of A. So if the potential is same, no charges will flow, na? So the capacitance is 0 over here. Here also it is V of B. Here also it is how much? V of B. Once again the charge will be how much? 0. So only I have to consider C. Got it? Is that clear or not? ठीक है? Or should I leave this? Wait, 1 minute. Undo. Let it be. Okay? So always just mark it. That's why I give you this question. Hard question. Do it now. Let me just bring the water. Do it. Okay, you might stuck in this question. You might feel stuck, isn't it? काफी ज्यादा टफ लग रहा है क्या ये? अच्छा, there is a trick to solve this kind of questions. There are many batteries, many capacitors, many loops, isn't it? So many batteries, many capacitor, many loops question is the most easiest one. You see how? Start anywhere. Start anywhere. I basically start from here by considering this to be 0 volts this to be 0 volts, and this to be once again how much? 0 volts. Got it? That day I taught you, na? For many loops system, consider down all to be how much? 0. And here batteries are given. You see one in one terminal here, only the battery is given. That means here the potential is how much? 20 volt. Yeah. Now, so 20 will go up, 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 but once again it met with minus 10 first or not. So here it is 20. Here it is how much? 20. Got it? So now remember that the negative terminal has how much? 0 volts. But the positive terminal has how much? 10 volts. So this 20 after coming over here, it will get added over here or not? So this, yeah, so this becomes how much? 30. Got it or not? Then here it is 0 and here it is 5. So once again I found out what? First positive. See when I found, अच्छा तुमको ये trick थोड़ा सा दिक्कत आएगा. Let me do it in a this way. That this is 20 and if it is opposite. See I'm considering, means ध्यान से देखना that I'm considering the first plate first. Word or not? Okay. The net potential I have to consider V2 minus V1. Are you able to get me? And if I find the first plate as negative when I'm traveling, then I'll consider it to be negative potential. क्या मानूंगा मैं? If the first if the first if the first particular plate is negative, are you able to get me or not? So look over here. When I go on going, see first I found which one? Negative. So that means it is how much? Minus 10 or not? So net change in potential will be how much? 20 minus of minus 10, which is how much? 30. So here I'll get how much? 30. Got it or not? Then you got how much? First as positive plate. This is 5 volts or not? So delta V is 30 minus 5, which is how much? 25. So this terminal is how much? 25. Got it or not? Next, if this is 25 and it is parallel, then it will once again, you see that, oh sorry, then once again you see that this is once again connected with the battery or not. Here it is how much? 10. So this one will, this is 0. So this will be only 10 volts or not. And here if it is 10, here there is only one line. So this one will also become how much? 10. Now you got the total potential on every part. Yes. On C1 also you got, C5 also you got, everywhere you got. So बोल रहा है every capacitor in the circuit has capacitance of 100 microfarad. Then find the charge on each capacitor. So if you get these kind of many loop system, they will not ask you equivalent capacitance because it is almost unsolvable within 2 minutes. Are you able to get me? So what they will ask you? Charge on each capacitor, which they are usually asking. So charge is what? Simple. Q is equal to CV2 minus V1 delta V, isn't it? So see here it is. Here there is no charge. Here there is no charge. On C1 there will be charge. So V2 minus V1 is 5, isn't it? And C1 is how much? 100. So this is 500 microcoulombs. I'm calculating Q1 over here. C2 is Q2. Q2 is how much then? C2 into delta V. ठीक है? So this is how much? 25 minus 0 is 25 into 100. That is 2500 microcoulombs. Are you able to get me? Q3 is on C3. Once again 25 into 100. So C3 into delta V, which is 2500 microcoulombs once again. Q4, on Q4 it is C4 into delta V. C4 is how much? 100 and delta V is how much? 25 minus 10, which is 15. So once again 1500 microcoulombs. Are you able to get me? Is that clear? And on this ultimately C5 Q5 C5 into delta V. C5 is how much? Just C5 is how much? 100 and change in potential is 20. So this is 200, 2000 microcoulombs. So that's your answer. So when you get these multi-charge, multi-circuit questions, just you establish this relation, you will get the answers. You have to just find the potential. Batteries will be always given. Okay? And if many more batteries are not given, then they will give you this kind of question. First type. And in first type, just find the potential at the junction and then you do it. Are you able to get me? Got it? It is easy peasy or not? Okay. Now, next type of questions which they provide is these kind of questions which have just showing the plates and they will ask you the net capacitance. Go ahead or not? Okay. So when you get these kind of questions, no need to once again answer. They have a once again you have to follow that method. Marking of the plates. So this is plate. Just take 2 points A and B. Got it? Here it is V of A. Here it is V of B. Got it or not? Once again V of A. Once again V of B. Now I start from the first point. V from V to VB. One I can draw one capacitor or not. When I go from VA to VB, isn't it? Because change in potential difference is there. Got it? Then once again you are going from VB to VA, means in opposite direction, but in which point? Another parallel one, isn't it? You have to always draw between A and B. Remember that. Okay. And once again VA to VB, there is one more. Got it? So all these three are in which type? Parallel connection, isn't it? So net capacitance is how? Simple. And since the gap is same, area is separation, distance D is there, area is also A. So they will all create a capacitance of how much? C, C, C. And where the C will be equal to epsilon naught A by D. Are you able to get me? Isn't it? So the C equivalent is how much? 3C, which is equal to 3 epsilon naught A by D. Are you able to get me or not? Isn't it? Then let us do. Oh wow! Once again. Now you do it. Can you do? Uh-huh. Yes. हेल्प करो मैं बना लोगी. Okay, let me tell you something. अच्छा देखो बाला एक बात बताओ. When we get the connections like VA, VB, VA, VB, means if there are of same potential, means if there is a change in potential, then we can draw the connections like parallel connections, isn't it? Here, this is V of A, this is V of B. How come it is V of B? They are at different potentials. I call it as V of N or V of M. Why? Because still some kind of induction process will happen or not. Got it? So they are at different potentials. So when we get all the potentials to be always different, they remember that they are always creating a series connection with the same capacitance. Got it? Because in series capacitance only, the net potential is totally different at every point or not. Got it? So here it is one C, another C, another C. Is that clear? So this is uh, V of A. Here I am V of M. Here I am V of N. And here I am V of B. Got it or not? So this is why C, C, C. So answer is 1 by C equivalent is equal to 1 by C plus 1 by C plus 1 by C, or C by 3, or epsilon naught A by D by 3. Is that clear? So Maya, okay. Do the next one. Do it fast. Less than 2 minutes you have to take. Do it fast. Once again, mark the potential. This is V of A. This is B. This is also V of B. This is V of A. C, C, C. Start doing. There are 2 points. A, B. No third point is there, isn't it? So first I'll start with A. First capacitance is done. Means I started from this point, I came over here. But then I found that these are at same potentials or not. So then this capacitance will become how much? Zero. Because at the same potential there is no capacitance, no current. Go ahead or there are only two. Got the idea? मजा आया? समझ में आ गया? क्लियर हो गया? ठीक. So then this is C, this is also how much? C. Right or not? So net C equivalent is how much? Twice C. Twice epsilon not A by B. Got it? Is that clear? Do the next one. Last. No, there are still one more. Hmm. So once again I'll mark V of A, V of B, V of A, unknown potential means V of N, isn't it? So when I first thing is what how I'll do mark the points A, then I'm going at B, then once again I'm going at A, then once again I'm going at A to N, isn't it? So I'm marking in at the B point. Okay, here N. Are you able to get me? So look over here. No, it's not at B point. I'll have to mark. Okay, let us first draw the diagram of A and B. You'll get the idea why I said that. Let us first draw the diagram A and B, isn't it? So first capacitor is done. Then VB to VA, second capacitor is also done. Then the third one is not connected with anyone. No? It's just a capacitor, but at N potential, isn't it? See, previously here what happened at the end B was there, so I got to know that I have to find between A and B. But here the problem is it is just there. So that means this is what useless because I have to only find between A and B. Got it or not? So this is C. This is C. Once again C. 2C. Isn't it? They're in parallel one. Yeah. Yeah. So they are. This is equal to how much? 2c. That means twice epsilon naught a by. Got it or not? Okay, can we move to next? Last. So this is how much? V of a. This is another one. So I call it as M. So V of M, V of A, V of M, V. So there are 3 points now. First, start with A, then M. First, because here till here I have A and M, isn't it? So first, let us connect A to M, and if it is going to get connected with B, we will have to see later on. Then once again A to M. Why I'm marking over here and down? A, M. Then once again, third one is also A to M, isn't it? But then B is M is not useless. It's got connected with B at the end or not. From top to down. So it got connected with B ultimately. And that's what we have to find. C, 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 C. So this is 3C and this is C. So C equivalent is how much? 3C into C divided by C plus C. 3C plus C, isn't it? So basically 3C by 4. This is my C equivalent, isn't it? Or C equivalent is 3 epsilon naught A by 4D. Got it? Correct now? पहले in top there is multiplication only now. Bottom is addition. Yeah. Is that clear? Hmm. Hmm. Can we move ahead? So we completed till over here. Now there is a point in capacitors which we call it, which we know by a name of breakdown voltage. But I want to do breakdown voltage, sharing of charges and heat loss at one go. Got it or not? So before that, see, here we have considered in all the capacitors, you see that we have the gaps between the capacitor, but these gaps are of air or not? Yes, isn't it? Like, see, we introduced in one of our topics that, yeah, so we introduced that in one of our topics, there is a point of dielectrics, isn't it? So, till now, we consider all the capacitors having what? Just simple, no such kind of, if we say, no such kind of, any kind of material which is present between the plates. What? Yeah. So now we are going to consider, I'm recording this session now. Yeah. So now I'm going to consider some kind of a medium which is present between the capacitors. Go ahead or not? The first kind of medium. So today, like the question which we discussed before, okay, same thing we are going to start. So first thing is the case one, when medium is itself a conductor, which you asked me a doubt. Today I was going to complete. Go ahead or not? Case one, when medium is itself a conductor. Go ahead or not? So let's suppose there are two plates. Okay, go ahead or not? And these are which kind of plates? Basically conducting plates, isn't it? So this is reason 1, this is reason 2, and this is reason 3. Now, the distance between the plates is still same, which is d. and surface area of the plates is how much? A. Got it. Now, in between it, you introduced a metallic plate. Got it or not? Got it. So this is normal plates. This is basically my metallic plate. Is that clear? Now, initially, so let us have a quick discussion that let's suppose initially the plates were charged, or the plates were kept at distance D, charged to potential B, charged to potential V. So that means what? They will develop the capacitance which will be equal to C is equal to epsilon naught A by D or not. Correct. Now when I just introduced them, now you see that these bodies got divided into two parts or not. Yes. So when I introduced, after introducing the metallic plate, what actually happened? This got divided into two parts. Is that clear? Yeah. But one thing is there, when we divide in terms of d by 2, when I connect them with the two potential, isn't this is looking like the initial case? Like when we divide in terms of d by 2 thickness and all, isn't it? Are you able to get me? So listen, try to understand that this is, look over here. Just now we discussed. See that when we have a division based on 2 points of plates A and B, we introduce some another plates. Then which kind of a connection it is? Series or parallel? Series, isn't it? So basically, when we divide in terms of D, it's an series capacitance. So net capacitance will be what? It will be the capacitance between two kinds of plates, and I call this as, let's suppose this is C1 and this is how much? C2. So series connection between C1 and, so now, so look over here, what will be my value of C1? C1 will be how much? Epsilon naught A, surface area is still itself, but D by 2 or not, which will be exactly equal to how much? C2. So therefore, 1 by C is equal to C equivalent is equal to 1 by C plus how much? 1 by C. Your C1 is equal to C2. Right or not? So C by 2 basically. C by 2. Look over there because C is epsilon naught A. So C1 is how much? C by 2 and C2 is also how much? C by 2. So therefore what I got, क्या आएगा ये? It's not D. Oh sorry, 1 minute. It's not C by 2. It's twice C basically. Yeah. I'm doing the, so 1 by, yeah, so 1 by 2c plus 1 by 2c, that means c equivalent is still equal to how much? C. So did anything changed? No. So when we introduce a metallic plate in this kind of terminology, then what happens? The particular equivalent capacitance never ever changes. Are you able to get me or not? Is that clear? Next point is, let's suppose if in between them, if in between these plates, I introduced one metallic plate, which question they gave you, same metallic plate, got it. But this time, I just connected this metallic plate with a wire. This is, got it. And initially also the distance was how much? D between them. Got it? So now look over here. Whatever the plus charges which were you having on this plate, since I connected that, and this one was having negative charges or not. So the point is, for any kind of a conducting material, for any kind of conducting material, the charge is starts to appear always on outer surface, isn't it? So when you connect with wire, the outer surface is this one or not. So basically this one will become the positive charge. So initially C initial was how much? Epsilon naught A by D. When the metallic plate was not introduced. When metallic plate was not introduced. Right or not? Now when I introduce the metallic plate, what will happen? C final will become what? Epsilon naught A by D by 2. So this 2 will go up or not? Yeah, so because this makes that C final is equal to twice of C initial. Yeah. In this case, the capacitance remains same. In this case, it becomes twice times. What then? No, not. Is that clear? And if it is connected with both, then once again same potential, so net capacitance is zero. Okay, so zero. So now first case we introduced the metallic conductor. Medium was metallic conductor. The second type of concept is like when we introduce case two, when we introduce which kind of which kind of dielectric medium. So there were two kinds of dielectric medium, polar and non-polar, isn't it? So when we, what kind of dielectric medium we have to take? See that. What was the difference between polar and non-polar? In polar, they have their own dipole moment but does not conduct electricity. And in non-polar, they are not, they do not have their own dipole moment, but under the influence of electric field, they get polarized and show some dipole moment or not. So polar dielectric will never ever conduct the electricity. Whether you place it in any field or whether you do not place it, it does not matter to it, isn't it? So, so what's the use of that? That's of no use because if I include polar dielectric, then there is no change in the capacitance. Is that clear? So that's why we introduce the non-polar dielectric. Is that clear? So if someone asks you that what if happens for polar dielectric medium? So for polar dielectric mediums, note as a leak learner for polar dielectric medium as it does not conduct electricity, the capacitance does not change. Is that clear? So, what we are introducing? We are introducing the polar dielectric medium. So I don't. So let's suppose if I Pinky Pinky Ponky, Daddy had a donkey, isn't it? Donkey died, Daddy cried. You know, whenever my dad used to got angry, he used to sing this song such that I will feel bad. I used to tell him, "You are my dad. You can't make me feel bad." He was like, "What?" Okay. So Control C, Control V, Control V, Control V, Control C, Control V, Control V, V. Okay. So let's suppose if I have any kind of dielectric medium, then it will have means what I did. I just took two plates and in between them I just introduced some some dielectric medium, isn't it? Which kind of dielectric medium? Non-polar. Yes. So basically, uh, if it is non-polar, got it. Okay. So basically, both can. I think. Okay. So this is this kind of arrangement. Are you able to get me or not? Now, see see what I have considered for polar dielectric medium. It does not conduct electricity. That does the capacitance does not change. It means that those kind of polar dielectric mediums which still remains solidified when the electric field is brought over there. Are you able to get me or not? Is that clear? But non-polar dielectric medium can still have little bit of polarity or not, because there is a little bit of plus minus charges in it, isn't it? So when there is no electric field, still they will have some plus minus combination. है कि नहीं? Are you able to get me or not? So now, so this is particular. The point is, I'm writing in the absence of electric field. What is there? The polar molecules are randomly arranged, isn't it? So look over here. See, the point is, many people will get confused, sir. You were saying that previously, like polar molecules are those kind of molecules which have polarity but does not conduct electricity, and non-polars are those molecules which does not have polarity but conduct electricity. But here you are considering some kind of a molecule which has already the polarity. So is it polar dielectric or non-polar dielectric? The point is, this is still a non-polar dielectric. Are you able to get me or not? Because we are just considering some shape of a particular kind of particles. Is that clear? We are not considering that particular consideration that yes, it is something like that, it is something like that. Is that clear? Yeah, so we are just considering that non-polar with some little bit of polarity, because the polar dielectric as usual it will be always fixed, it will not conduct any kind of electricity. Is that clear? Yeah, so we have the polar molecules only, not the polar medium. What we have? Polar molecules, not the polar medium. Okay, which have already some little bit of dipole moment and they are randomly present. Is that clear? And at this time they are not conducting any kind of electricity. Is that clear? So now, what if I just bring what if I just bring the electricity, means external electric field, in the presence of these polar molecules? What will happen? Then you look over here, they will start arranging basic outside. So what will happen? After this, they will start arranging in this form or not, means they will start arranging themselves in the form of electric field, isn't it? Got it or not? So you'll see them arranged in this fashion, perfectly arranged now, because they have started conducting the electricity, or they have started having the presence of electricity. Are you able to get me? Is that clear? So now look over here, when I have the electric field, this is plus plate and this is minus plate or not. So what you will see, that negative charge is getting present over here. This negative, this negative, this negative, this is plus. And this will become what? Minus, plus, minus, plus, minus, plus. Are you able to get me? Which are created due to this dielectric medium which is present between our plates, same, having the same thickness t as of the distance between the plates d. Are you able to get me or not? So look over here, if this is plus and minus, can we see that they are generating some kind of a induced electric field in the opposite direction or not? Which is E induced, isn't it? Are you able to get me? So look over here. Basically, I'll post it my hands. Okay. So you try to see that first thing that I have this as E naught. Yeah. So E naught is electric field in air. Got it. E is induced electric field. Is that clear? And then I'll have E net or not. That is net electric field. Are you able to get me? And you know that due to polarization, some charges are only developed over here, and due to that, only some electric field is only getting developed, isn't it? So therefore, the net electric field will be still in which direction? It will be in the direction of presence of external electric field. Are you able to get me? So this is my E net. Are you able to get me? So look over here. So can I just write E net is equal to nothing but E naught minus E indexed. Is that clear or not? Are you able to get me? And this is the equation of electric field which I described you earlier. Is that clear or not? Are you able to get me? But the point is, let's suppose if this dielectric, you know that if this dielectric is of dielectric constant K, okay, so let me introduce it over here only. So if the dielectric medium have dielectric constant kappa, then E net means the net electric field developed is E by K or not? E naught by K means electric field in air divided by, because it is developed in full medium, isn't it? So you know that basically how it is coming. Previously we discussed now that whenever you submerge in some kind of a higher density material, then that in that what happens? The field gets reduced by 1 by K times, isn't it? So force also used to get reduced. Similarly, field will also get reduced, isn't it? So here that is why you see that when K is introduced for whole length, so that is why the particular E net gets reduced by 1 by K times. Are you able to get me or not? And that is why we write induced electric field, E induced, as E E naught, uh, E naught minus E naught by K, which is E naught common 1 minus 1 by K. Got it or not? Is that clear? Now remember, that for metals, as we considered, E net is always equal to 0 because the kappa value is infinite for our metals. Are you able to get me or not? So that is why if you introduce a full conductor inside in between the plates, not between the plates or half, then what will happen? Then the net electric field will become how much? Zero. Is that clear? Are you able to get me or not? ठीक है? Good. So can we move ahead? So look over here. Let us have the cases. So let's suppose I have two plates. Okay. And in between the two plates, I introduced my dielectric. Why don't they are very, very much fun. So let me draw. Why I'm drawing this? I have everything. I introduced my dielectric medium. Is that clear? So then, what will be my capacitance? We want to see. So this, if this is charged, th- sorry, if this is charged, this will be plus Q, and this one will be minus Q or not, isn't it? And due to that, you see that, sorry, this one in minus in the dielectric field, and this is what? Plus. So this is what? Yeah. So look over here. This is minus of Q induced, and this is plus of Q induced in the dielectric field. Is that clear? Then still my net electric field is in forward direction, and let's suppose the distance between the plates is D, and area of the plates is how much? A. Then C initially without uh, with yeah, without dielectric was how much? Epsilon naught A by D. Are you able to get me or not? So with dielectric, let us see what happens. है ना? So look over here. With the dielectric C. So first thing we need to find the electric field over here. So electric field is how much? You know that it is equal to क्या लिखेंगे? Sigma by epsilon naught into, because it is, since it is dielectric of dielectric constant K, so electric field will become 1 by K times or not. So into 1 by K. Innate is this thing, isn't it? So this becomes how much? Q by area A epsilon naught K. Got it or not? And that is equal to potential by distance, the change in potential by distance D, because these are two equipotential surfaces, isn't it? So V I got as how much when you introduce QD by A epsilon naught K, isn't it? And Q is equal to what? CV. So you got what? This implies that C is equal to क्या लिखेंगे? AK epsilon naught by D, which implies that the new C, new capital C, is K times C in air. Are you able to get me or not? Got it? And this is called as the relation of capacitance with the electric medium. Is that clear? ठीक है? ठीक है ना? आगे बढ़ा जाए। अब ध्यान से देखो। सो नाउ लुक ओवर हियर। नाउ वी नो दैट basically electric field induced is how much? Right now we got the formula is equal to E naught, sorry, E naught 1 minus 1 by K or not? Yes. Now, electric field induced will be what? This is my charge induced. Charge induced by area A into epsilon naught, isn't it? And E naught is what? Similar, simple. It was original charge Q by area A epsilon naught. Are you able to get me? 1 minus 1 by K. So this implies what? We got the formula for even charge induced, that it is equal to, so this implies that Q induced is Q 1 minus 1 by K. Means whatever my original charge was there, it becomes 1 minus 1 by K times. Are you able to get me? समझ में आया? ठीक है. अब एक बात सोचो जरा. When we have the plates, the point is when electric field is there, then the plates are basically attracting with each other or not, because they have opposite and equal charges. So you need to put some external force to keep them at rest or not. So let us talk about this force between the plates. Okay, so see that when we talk about the force, no one actually talks usually. So force is what? Simple kq square by r, isn't it? But here I am feeling due to charges, isn't it? So can I write q into electric field E? And this is the force of attraction between two plates. Force on the one plate by the other plate, isn't it? So Q E is how much? Epsilon अगर हम देखें sigma, if the dielectric is not there. So force in air I'm asking. Okay. So it is how much? Q by A epsilon naught. Are you able to get me or not? But see that this, yeah, so this electric field, see this, these charges, the total electric field is due to what? Because of the charges on both the plates or not. So I need to divide by how much? 2. So therefore force in air is how much? Q is. Yeah, I'll tell you once again. See, the point is that when I talk about the electric field, so net electric field is sigma by epsilon naught, isn't it? But the one plate feels the force due to the electric field of only one plate or not. So E of one plate is how much? E of one plate only. It is sigma by 2 epsilon naught. No? Got it? So sigma by, this is what? Q by twice a epsilon naught. Are you able to get me? Due to this electric field of one plate, the other plate is feeling the force. So this is E of one plate basically, you can say in terms of understanding. Is that clear? Yeah. So always we have to use capacitance in terms of dielectric as K into C of air. Is that clear? Okay, now the question arises that how you are going to consider it. So basically now the point was to do this, but I think we will not have enough time. We did so many questions today, isn't it? So now can you handle it? The point is that dielectric, tomorrow we'll have one more class where I'll tell you if you fill the capacitance partially, then what happens with the capacitance? Is that clear or not? Tomorrow is which day? 12th now? 12th. Okay, let me stop the